Yeah. Let's just change this one.
The private wiki, right? Because we're getting rid of the public wiki.
It's got on the part one.
Okay, what am I looking for?
And you can go look for my space. My space is a public space on there. Yeah, there you go. Fantastic. So pull up this very first one. We're going to
The
go
missionary
through.
domain.
No, the CS application one. So I'm going to give you a little bit of context. So if you scroll down, I'm going to show you a context diagram, and this is a real one that I'm working on right now. And so this is the thing I wanted to kind of point out of this context diagram is I'm focusing on the CES profile area for several applications right now. And it's got a whole bunch of domains that it interacts with. This application, in order to be successful, will be a very distributed application. I'm going to be getting information and sharing information with, and some of those boxes you see in there represent 5 or 6 things. Like I'm going to be getting academic record information from at least 5 different systems, possibly 7, in order to make this successful. I'm going to be getting identity information from at least the 4 major institutions and the LDS Church. I'm going to be getting those kinds of things. So, to begin with, by the end of this year, I am going to have to be working with at least 13 different systems, real-time distributed systems. So, this is going to be kind of an interesting one. So, one of the things that I did is I started saying, all right, we've been talking about microservices, event-driven, all these kinds of things. We've been talking about a nice RESTful API that is called in a synchronous fashion. But we've got this thing here about asynchronous kinds of APIs. And so I went ahead and I put together a diagram, and I kind of tried to identify some issues. So if you want to go look at the alternative number 1, I did a real quick thing here on that diagram, the missionary domain. And really what the missionary domain is, the heart of the missionary domain is, if you take a look down here, is we've got the LDS Church saying, great, we'll provide an API for you. This is a synchronous API call that will return missionary information about individuals. They're very restrictive on what we can use it for. I can't publish it on the web tomorrow. But they're going to provide this that gives me accurate information about missionaries. By the way, we also have the problem of, at times, especially in certain kinds of places where people make applications, they want to self-report things. They want to say, I did a service mission or different kinds of things. And to be honest with you, I don't know that they make a tremendous amount of difference in the admissions process, but they make people feel really good that they can give us that information, so we let them do it. All right? So I came up with a domain here, and I said, now, in our domain-driven design, this represents the missionary domain. Now, I'm not attempting to describe what the church does, but this is my domain to front-end my call to the LDS Church. We've got this concept of here of the University API domain. Everybody's heard a little bit what we're talking about there. That is kind of our public-facing API, and it's a layer of abstraction on top of all of our other domains and APIs. So I don't let everybody in the entire world call the missionary domain or the APIs of the missionary domain. I say, you come to the University API, it'll be the front-facing one. Anybody can subscribe to the University API, and then it will make calls down into the other APIs, into the other domains. Why would we want to do that? It's because then I don't have the technical debt on my domain. I can change it fairly easy. I have that layer of abstraction. So let's suppose I got a screen. I put a Polymer component on here that deals with missionary stuff. And I think the missionary domain team should have to build that Polymer component, at least as a start one. It makes a call into the University API. And then from there, I'm suggesting a rather interesting way of working. The University API doesn't turn around and make a synchronous call. In a second, I'll show you an alternative, or maybe it does. Instead, what it does is it raises an event on calling the missionary event bus. This is not the interdomain event hub. This is a very private missionary event bus, and I'm careful until I get permission to put things on here. So this guy raises a missionary data requested, let's suppose. And what happens in the background, because I want really good resiliency, I want good performance, and I want to protect the LDS Church API. Not security-wise. The thing I don't want to do is I don't want to do from some of the people on campus are doing to me. Hey, your web APIs suck. They're down all the time, and every time they're down, my application is down. So I want to let the LDS Church function, and if they have problems, so what I'm going to do is off this event bus, I'm going to grab this missionary data requested, and I'm going to build a microservice that is the circuit breaker pattern. And that guy makes a synchronous call to the LDS Church. He's got the credentials, the only place that they exist. He makes a call, and if he gets the data, he's going to say, data retrieved, and he's going to put it back on the bus. I'm going to have a little bit of a circuit breaker technology database here that says, by the way, if I've had a problem, I'm going to shut down, and I'm going to very quickly answer, hey, I'm shut down. And then after 5 minutes or so, I may try it again and do that. I'm going to keep a log so that I can come back and actually look and see when I was down and what problems really were. Okay? So I've got this great thing. So, but I don't ever want to have my application be down because the LDS Church API is having a problem, or they did the thing that they did 2 months ago, change all their URI names and didn't tell anybody. Okay? But I don't want to do that. So I'm going to have a second thing over here that I'm going to call missionary cache. It's going to be kind of a standard template pattern. And when the missionary data is requested, this guy's going to hear the same one, and he's going to go out to the cache. He's going to say, have I got that data cached for that particular individual you're looking for? If I do, great, I will give it to you. Now, the attribute that's going back, this guy would have, the attribute may have said data, date, time, cache. No. This guy's going to say date, time, cache 7 minutes ago because of bouncing around on the screen. Guess what? This guy back here is a scatter-gather pattern. He's sitting out and he's getting both those messages back. And if he's got the one from the LDS Church that's as of, 2 seconds ago, he'll use that one. But if he doesn't get it back in enough time, he's just going to take the cache value and says, hey, that's only 7 minutes old. I'm fine, happy, great. I'm going to pass that back. And the rules of how old the cache can be and still be valid may be different for different kinds of data. Let's be realistic. If I get back missionary data and it says it was cached 30 days ago, I'm probably just fine. Missionary data doesn't change that often, right? So I'm going to have this cache answering the same question, and this guy is working off a scattered data pattern. By the way, the person may have also self-reported some missionary information, so this guy's also listening to the missionary data requested and returning an answer. Does that make sense? Now, this cacher is smarter. He is also listening for these missionary data retrieve messages and saying, oh, by the way, if the LDS Church sent back a message recently, I'm going to look and I'm going to take that missionary data retrieved and I'm going to update my cache if it's more recent than what I've got. So he's just listening to that event and taking care of it. If I do change my cache, I'm going to raise a missionary data cache event. Because I got over here, these guys listening for missionary data cache, which means a real change in the value. Last time we got from something from Salt Lake. And I may spew that out onto the event hub in case any other domains care. And I may put that in my system of record in my Oracle database for warehousing purposes. So there's all these kinds of things going on. If some other domain, like the BYU Idaho guys, found out an updated missionary data and they raised an event for me, I may take that and as a result of that, update my cache with something that's more recent. Making sense how this works? Now, it's completely asynchronous. I've got the level of resiliency in there. I'm actually answering the question of missionary data from 2 different sources, from the LDS Church and from my self-reported stuff. This seems like possibly an interesting way. On a very, very simple domain is a way to do it. Protecting this guy, guaranteeing performance. If this was written in a scatter-gather pattern, it may say, I only wait 2 seconds. I take the best that I've got at that particular point and go, boom. I am not, because it's University API and the emissions thing, probably going to be hitting on one single invocation 13 different systems. I don't want to tie myself to, if any of them have a problem, I fail. I'm working at the slowest rate of all of them. What I want to probably be doing is saying, after 2.5 seconds, I give the best path possible answer, right? So what could possibly happen in that situation? So I get the call, it sends out the message to 15 different domains, getting the answers. In this one, down came the request for the missionary. The missionary cache answered virtually instantaneous. And it's only 10 days old, let's suppose. Meanwhile, this request went out to the LDS church. The LDS church has got no performance issues, or whatever the case may be. He doesn't answer for 7 seconds. This guy up here said at 3 seconds, the answer goes back. The answer went back to the screen, it showed the cache data. Right? But this one comes in at 7 seconds, what's happened? This guy doesn't care. But this guy does, and he updates the cache. They come back in another minute because they're moving around on the page. Now, even though the LDS church is still pretty slow, he's getting a cache answer that's only 3 minutes or 7 minutes old. So I've built a great deal of performance resiliency into this.
Might I add another possible fun bit? If your UI had a WebSocket connection
Yes.
to that event bus, all of a sudden it has bidirectional communication. And instead of sending a query through the University API, it just dispatches through its WebSocket connection a missionary data requested command.
I would still think it goes to the University API, but could the University API have an asynchronous layer of abstraction? Sure, it could.
You could essentially have a documented WebSocket thing for University API.
Yes, we could.
But
And Josh keeps talking to me steadily about WebSocket, and it becomes solid enough. I think we should do it.
what do you mean it's not solid enough?
I think it's really solid.
Mm-hmm. It's being used all over the place for Google scaled apps.
Yeah. And as we get solid enough that we know how to do it, we know how to handle all the security and the authentication issues. Yeah, I think
We should
it's
look at
really.
Firebase.
I think it's really good.
It's a Google project that's built around WebSockets and abstracts it away from you.
I think we
And
should
you
look
can
at it.
push data, like you could push data from our systems into it. But yeah, you have that WebSocket, then your UI, when it receives that cache data, it displays it. And then it receives the better data from the church, it displays that.
That's the objective where we go. Well,
Yeah.
We'll talk a second about a couple things in here as we get down in here. What are we missing, I think, in my mind, to really be solid where we're at? Okay, so let me ask a couple questions here. What do you guys think of this? What improvements would you make in this model? Because I'll tell you some of the concerns that I've had and some of the discussions that are going on, but I'll let you guys think. Sort of.
I'm not, something caught my attention was that the cache wasn't transparent. It seems like you could have a circuit breaker pattern with your cache and have it be in line with the request. And, so like,
So the circuit breaker itself was caching.
well, yeah, and then the circuit breaker could decide. It seems like we'd want the endpoint where we talk to the LDS Church API for the missionary data, we'd want that to decide how long a valid cache is and not further towards the top of the diagram. And, like maybe I don't want to have to deal with or figure out what type of pattern. Do I only listen for 2 seconds, or do I only listen to 5 so I can get better data, or am I going to get some? It's like I'd want the back end to just take care of all that.
Well, so that's an interesting question. That's very interesting. Come on. Okay. Now, one of the reasons I didn't build it into, if this guy thinks he's down, he goes to cache, is I wanted to be able to say, cache, give the answer as fast as you can.
Yeah.
And this guy, if he comes back 7 seconds later and ends up updating my cache, I wanted to separate it.
You still don't get the benefit of even a slow response. Which makes
I want to
sense.
get the benefit of a slow response because it updates my cache.
Yeah,
And
it seemed like that question got raised right away for me, but then it seemed like everybody else listens to that cache event, and it kind of makes sense, but it still means that I have to deal with it.
I think cache validation, though, too, can happen in the cacher. The cacher itself can say, yeah, this data is 3 months old. We've considered that invalid, and so it just deletes its data.
I would-
And so it wouldn't be
Also-
able to respond.
Yeah, that is an interesting question.
Yeah.
The rules around how long, and doing my garbage collection, that's probably something that belongs in this domain that I have to do.
Yeah, and I think that,
And do I have a batch processor, or do I just build in the smarts in here that it says, Oh, I go to get it. Oh, this is too through.
Yeah, I mean, and then at
Basically,
that
every
point, it
caching
just
engine
stops
has
responding.
A good implementation of that.
Yeah.
Okay.
And what you could do is on the response messages, when you request the missionary data on the response that has the data in it, you could set a time to live field on there that says, this is the maximum amount of time you can cache this is this amount of time. So that way the church can say it's a week, the self-reporting can say, they can come in and change it at any time, it's cacheable for a day.
Yeah, I think if anyone is passing in TTL headers, obviously those should be respected by whatever our caching service is.
Yeah.
A lot of
TTL in
times
there.
the church probably isn't passing back a TTL right now.
Well, but
No,
our interface
They're not
here,
that sophisticated. It
Yeah.
is in our data sharing agreement.
So I mean, it seems really glorious and complicated too. Like I read about somebody they were going to retire their API, and so what they did is they put a Nginx proxy in front of it and cached it for a couple months, and then they took out the backstream API, but they keep the proxy. Now, I mean, just so simple that there's a little bit of it seemed cheating because it's too simple. And this would. I mean, the goal is fast response and protect that upstream API. And it seems like there's a lot here, like a lot of bandwidth, a lot of messages.
Yeah.
Is that an issue or?
I like it. I mean, I like the fact that it's just decoupled. I mean, we're getting a lot of benefit out of the decoupling of it with that we're able to update the cache and everyone else on campus just because we happen to call the LDS API. And if there's an information change, that triggers an event across everyone across campus, which is a nice side effect of we're already calling it, we're already getting that information out, why not utilize it? And I like that.
It might seem like a lot of messages, but it's probably still lower network than polling.
Yeah, absolutely.
Yeah, it is.
Absolutely.
And one of the reasons I'm saying I think this isn't the bus, the traffic that's happening on this thing, that's all flowing around, is not impacting everybody else.
No.
The only bit I'm putting up there is when there's a change in the data, which
Exactly. I mean, it's nice that we can make our caching services and our circuit breakers work completely asynchronously. We're not, blocking things by waiting for the cache to update or something like
So
that.
is this something that we could put together and use on every single external API that we depend on?
I'm suggesting that.
Yeah.
And that's why I'm bringing it here to kind of review. That some of these things like a cacher, the data that I'm caching in the business rules change, but the logic of this is the same. A circuit breaker, I build this one time. All I'm changing is the data that's getting passed back and forth and how I connect to this external API.
Yeah.
I don't think I should have an external API without having a circuit breaker
you should
and a cache. Okay? And if I have additional information, I'm kind of showing how that fits in. I am pulling off these microservices things. The only thing that knows how to take this entity, missionary data, and turn it into the relational database is this guy. Nobody else worries about that.
Yeah.
They're passing around the entity, always. Now, one of the interesting questions here is, in this original diagram, I put the scatter-gather logic up here. Everybody know what I mean by scatter-gather?
Yeah.
I put it up here. And that's really an interesting, problematic question. And it goes to the following question. Now this guy has to understand a little bit about this domain logic. That's a negative.
Yeah.
To be able to say, he's going to be getting all those back. But it also puts it in this guy's court to say, oh, for this particular resource that I'm, they're asking for missionary in the context of whatever, my rules may change. I can only wait 1 second versus 3 seconds. I have to have cache that is so recent, or I have to say not available right now. By moving it down here, it's always one answer. Is that always what I want? Or I complicate the contract of this guy having to communicate down to everybody what my rules are. I have to have this answer in 1 second, or I have to have a cache that's only so. That's where I'm going back and forth. It's a trade-off of how flexible do I need it to be.
You can't have a translator service, like a app on the bus?
You could. I think a lot of it too depends in. So there's two aspects to the University API. I don't know if everyone's aware of that. When we talk about the University API a lot in a lot of different ways. And the University API, there's two things. There is a standard that we're coming up with that we want all domain APIs to follow. You know, what are good practices to create a REST API? And then there is an actual binary blob program that will front a yet to be determined set of resources. Right now, a lot of it has been discussed as instructors, classes, courses, and students. You know, so those kind of main core things, and it will actually go through a single program. And I think
Which allows everybody out there to use it without every domain taking on the technical debt of those contracts.
Exactly.
They can change, and all I have to do is change one spot. That's
exactly. No, absolutely. I mean, because the reason we're doing that, yeah, is exactly. There's a lot of information, for example, about a student that comes from currently probably 50 different APIs, and we want to centralize that. But at the same time, there are still domain APIs that will always exist. Things like Secure are not going to go into the university API. They're not. You know, door locks aren't related to those kind of core resources.
Right.
But I mean, I think that has something to play with it too, because I think that in the university API, if it's actually in our program university API and not just standardized, then maybe it does have value in separating that domain logic out of the university API and letting the university API just call, you know, basically a missionary backend service. Whereas if it is its own, it's just following the standard, it's not part of that main resources, then in that case, I think that it's okay to put the logic there. I feel like it might be a little bit more logic than we care for in the university API.
I'm kind of agreeing. I feel like it's a little too much, and we've discussed some of those things. But, okay, so alternative number two.
Do they call that a tab? Is that the terminology that's used on the bus?
You can call it a tab, you can call it a translation service, there's the anti-corruption layer, there's a lot of different terms for it.
One of the things is if you scroll down on this page, I did some interesting, I'm kind of trying to suggest maybe where this thing is going. So like if you notice, I put things in here which I would love to have people react to. So I said, this is what the event bus is. So I said, most of the requests will be raised, I think, to the missionary from the university API. Mm-hmm. This alternative would require the university API. This alternative would require the scatter gather to be there. Yep. Good or bad, I don't know. University API will listen from responses and package them. Missionary requests and responses will be doctored in the standard schema and will adhere to the BYU event protocol. We're going to talk a second a little bit about what that might mean. It would be preferable if the missionary event bus was deployed with an HTTP interface, kind of like our domain bus, so that I have the layer abstraction from the university API. When I cross domains, maybe I should be using HTTP, not directly through AWS. That's kind of what I'm thinking and suggesting. But inside the domain, I don't care if they're, if each of these workers are just straight on the bus, okay? I think we should have to consider modifying the BYU event protocol so that we're passing the JWT in the message. The reason is if what we're saying is these are now asynchronous APIs, that's one of the things I'm going to be talking about. The worker down there has to be able to validate the identity of where this started from. I just can't assume that it's getting passed to me. That doesn't seem very good security. Now all of a sudden where events are just not, something happened, do whatever you want to do is, this is a request for you to do something, I better send along who requested it so I can do proper authorization. I think we need to make that change. We may also want to consider modifying the event protocol to include Helios type links when I'm sending it back. Because if you'll notice in my diagram, I was saying this nice secrets API where we're going to try, we're suggesting a level of maturity where I've got Helios links. Where do they come from? The university API hasn't got that smart, so they better come back in the events.
Yeah.
That, yep, I'm giving you back data, and what are the possible states that resource can now happen? I better get those links there. So that's an interesting thing that we need. That's a level of maturity I think we need to get to before we can start even going back to the clients. Okay? And I think the missionary event bus is probably just implemented with AWS SQS, and I think RabbitMQ is overkill for domain-specific event buses. Okay?
Yeah.
I put in some notes here, which you guys can read. I think this circuit breaker does two things. It protects them, but it also acts as the anti-corruption layer from whatever I'm getting. So they can change their stuff, and I can change it into our language. I think that's an important one. I think it's just a Lambda function. I think that's how it should work. The circuit breaker is just a simple DynamoDB instance. The specification, this one here, this external one, out of my control. Okay? Now, it's interesting, I say external to the LDS Church. Let me ask an interesting question. Even in between domains, if I'm working with somebody, some other API inside of the university, like I'm going against an HR one, and it's really critical, I maybe should be putting a circuit breaker in there even to do those kinds of things. So external is, at least anything outside of my domain ought to be considered that way. So these ones are pretty straightforward. Missionary cache, I've talked about its attributes, all those different kinds of things. I'm actually suggesting possibly, you know, implementations and things, stuff like that. Love to have everybody's response, looking at it, seeing what they think. Okay? I suggest a lot of these workers are just Lambda functions, but I'm open to what everybody suggests in that. Okay, there it is.
Yeah, no, as far as the Lambda go, I mean, I think that's exactly what Lambda was designed to do, was to be an event driven. I mean, I think that's fantastic for all of those kind of things, for the anti-corruption / circuit breaker layer, for the caching layer. And that is exactly what Lambda was built to do, is listen and respond to an event and be dead.
Yes.
And I think that that's a fantastic use of it.
Okay. Please vote alternative number 2.
I will say that for the circuit breaker, Lambda may not quite be the best fit, because the best circuit breakers are ones that are stateful.
Yes, and that is true.
They can keep track of, okay, so how long have I been open, so that I can start, all right, I've been open for 30 seconds. That should be enough time for them to recover. I'm going to start letting it trickle through to see what
So
happens.
instead of keeping that state in a database,
In a database,
Yeah.
keep it in memory.
just keep it in memory. That might
Well,
be
you could do it in a
good point.
database,
That might be a good point.
but most of the existing implementations, which we probably don't want to write our own circuit breaker,
Yeah.
most of the existing implementations use in-memory
Yeah.
stuff.
I think that,
Well, really good point. Maybe I should,
So-
just change this.
Just
Okay.
the golden standard for circuit breakers right now is a project called Hystrix by Netflix, and it's written in Java, and it's all in-memory stuff, and it uses thread pools and things like that. But that's also something that we can just spin up on a little T2 micro.
Yep. Okay,
Yeah,
good.
and one
Those
thing-
good feedbacks. That's why I'm presenting this. Yes.
I have 2 more things real quick.
Yes.
One thing that we can keep in mind is that, at least for internal stuff, it's a little harder when we're dealing with the LDS's API, because that makes it a little bit harder in this case. But WSO2 can easily act as our circuit breaker for anything in or BYU. WSO2 allows us to be able to set up all sorts of circuit breaker type things, that when things error out, WSO2 just starts kicking back. Yep, nope, it's failed, and it actually has timeouts set up for that kind of stuff.
Cool.
So WSO2 will allow us to do anything like that, like when you were talking about like the HR kind of stuff, putting those kind of circuit breakers in. WSO2 does that exact thing for us. Calling out to the LDS Church's API is a little complicated with WSO2, because they don't know our authentication, and we don't want to force you to use their authentication through our gateway. But for intra-domain stuff, intra-domain, that's what I was trying to say. For intra-domain stuff, or even intra-BYU stuff, WSO2 works great for circuit breaker.
Great. That's probably what we ought to be doing.
And then my second comment is, now granted, on that circuit breaker thing, that is up to the API developer. The API developer who defines the API sets up his own circuit breaker rules. And my second thought is, I think Hadios is absolutely necessary for our event hub. I think Hadios links in the event bodies is where we have to go for discoverability. I know that you and I have talked about that a little bit. Brent and I have talked about that. And for the discoverability that we want, I think Hadios absolutely has to be there.
Yeah. And then I'm going to go back and suggest an interesting standard.
Okay.
And how that gets back. And that's where I was going to talk about this asynchronous nature before I'm ready to say, oh yeah, let's take advantage of WebSockets and the browsers. How are we going to do all of that kind of stuff? That's what we got to figure out. So now I drew a second diagram, an alternative based on some of the feedback. And now this is getting a more complex for a fairly simple domain. So now I said, all right, let's take the scatter gather completely out of that guy. And somebody, Josh, I think, made an interesting suggestion. He said, what if, kind of going back to the DDD concepts, I've got these different portals. What if I say, I've got a missionary interface event bus, and I say, this is where you talk to me, guys. So you put your requests on here. This one is an HTTP. That's how you can deal with this. You don't ever get down to my private event bus manager. Nobody does. So what I do is you put your data request, and I'll give you your answers back through here. And by the way, the scatter gather is now under my control, which is probably okay in missionary. I mean, to be honest with you, is anybody out there gonna have a lot of different cases? Probably not. So now I bring the scatter gather inside. I also drew, and maybe for completeness is, I'll also let you make a synchronous call. What is the synchronous call? It just puts it on this plus here. And I did. So I draw that as an alternative for consideration. I got to finish down at the bottom describing these new components, which I'll do. But does that make sense?
Yes.
I would love people's feedback if I'm missing major components, because I really believe in, if we make these microservices small, that we're literally taking either somebody's open source or something like that and saying, oh, bam, boom, here's how it goes. What are the parts that you change when you move from handling missionary data to handling seminary institute data to handling whatever, and you just literally almost stamp them out.
Yep.
We want them to be so standard, I can go into someone else's domain and say, well, where's your spewer? Oh, okay, yeah, great, that makes sense.
Yep.
There's particular logic in there of what gets spewed, but
So I have some questions about this one. In the interface event bus, is the intent to allow the client private domains to speak directly to the university API or the missionary API? Or are we intending that to only go through the scatter gatherer? Does that make sense what I'm saying? So like here, if,
no one gets access to this.
no, so what I'm
It
saying
has to go
is
through here.
here on this, because this we're marking as listening for missionary data updated.
Uh-huh.
But here we're also saying that this one, at least before, said missionary data updated, I thought. Okay, maybe I just updated it.
No, well, yeah, if you notice before, I call it reported here,
Uh-huh.
and it comes down, and you do reports, and then they end up getting updated.
So then, in that,
Updated is different than, a client reported it, but I haven't updated it yet. Updated means it's been
and that
accepted.
makes sense. And so then in this case, I don't know why we'd stick the event bus here if the only thing that is ever going to listen is this. Instead of just making everything make an HTTP call to the scatter gatherer itself, I think that the event bus, I mean, that's really all we're doing. And so I think that the event bus complicates things just a hair. If all we're doing is trying to get something to the scatter gatherer.
It does complicate this, no doubt. But the reason I've wanted to put that option here, because this is really doing it, is this university API, I don't want him to have to make 13 synchronous calls.
Yes.
I want him to, you raise 13 events, now he is listening, in essence, he's kind of doing his own scatter gather, but he's not having to analyze these different answers here.
Yeah,
This
no,
is
and
analyzed.
well, and I was thinking still use the scatter gatherer. I'm just saying why not let the university API call the scatter gatherer directly instead of, because it's raising an event that only the scatter gatherer is listening to. And so instead of raising the event to be listened to, why not just call directly? I mean, the one thing I can see is that with the event bus, we can call it an asynchronous thing where we're kicking out and then just listening, whereas this would be probably a synchronous
Call.
HTTP request.
It would be,
But-
it'd be as instance taking these two and melding them.
Uh-huh.
Mhm.
And so that was my only thought, is that I think that the event bus, besides the benefit of being asynchronous when we're listening and actually listening on the real protocol and not just the asynchronous, or the synchronous HTTP request, it seems like we could also maybe get rid of that event bus.
The one value of the event bus was not necessarily from here down, but just it was from here up. That guy can literally say, missionary domain, and you just do all these asynchronous events, and he's doing his own form of scatter gather,
Uh-huh.
but he's not having to analyze all of these gathers. that
Well, yeah, and I'm
he's only getting one answer back. from
Yeah,
the
and I'm
missionary.
still saying let this scatter gather do all of that analyzation.
Uh-huh.
This is all the analyzing. But it wouldn't, instead of the scatter gather reporting back to the event bus a single thing, it would just report back directly to the university API. Because this, I still think the scatter gather, yeah, is absolutely necessary because the university API should only have to make one call and receive one response. But I think that we can do that without the event bus because the scatter gather is already going to do that, as far as I understand. Unless I'm understanding what we're doing with scatter gather.
I think you're doing it right. Yeah, I think you're understanding okay. I was just trying to allow him to make his call either synchronously or asynchronously.
Yes, and that is the benefit I do see of the event list is that we can do it asynchronous.
This is the most complicated, I think I've got the most complicated case here for one of the simplest domains. So it's probably overkill, right? But if you get a more complex domain, like I'm trying to talk to the academic records at BYU Idaho, where there's a lot of events and things and stuff like that, it may justify having an interface bus and a private bus where a lot of things is flying back and forth.
I agree, and that could be. But yeah, I mean, in this case, I could see, I like if we kind of mix the two. I like how the first alternative was presented, but if we added this gathering separated from the university API, I like that.
Now, one of the things I was also doing, like I said, I kind of went to the two extremes for a good reason. I think as domain designers, you would say, I don't need this, I don't need it. I'm allowed to choose the components that make sense for my domain. But the components I choose are standard components. And I think there's a real value in that.
I agree. I think there's a value in being able to standardize all of it, even if it's not all necessary.
Right, and then I choose the ones that make sense. And maybe I could come up with the domain that I'm never going to catch.
Yeah.
Just isn't. I'll just give you back an answer not available. Okay.
Yeah.
But those are some things. So I'm interested for people to kind of look at it, give feedback, because this is sort of an architecture that could fit for any domain, I think. And then one of the things I want to do is maybe come back on a Crazy Friday. I was going to ask Paul this year. Let's schedule a workathon, and if we get I start on it, everybody do one. Build up. The simplest one I could think of was just I intentionally chose missionary.
We have one feedback.
What's that?
Why can't those lines just be straight?
Well, what's interesting enough is I was trying to make it so that everything looked good at everything, get it all lined up, and I'm doing it right now. And then when we changed, it all melded in anyway.
No, it actually is really good. I was trying to think of some backup.
Yeah. The answer is I was changing it on the fly. I mean, there's other alternatives. So okay, so just that was what I wanted to do. Now, it led into the item number 2, which is the asynchronous API concepts, which is we're really introducing this next animal of, now we're not just raising events, you do what you want, we're raising events almost as requests, as commands, and expecting back responses. How in the world do we document these things? And that goes back to the question earlier of the developer portal. It's really cool to be able to go and say, I have a Spider document that defines everything, and I can see what's going on. Where in the world do we have, this is a little research project, we're talk about, maybe we suggest a standard back out there to the community of how do I define my events and link events that, hey, if I raise this event, here's the possible events I could expect back.
Yeah.
And can I expect back one only, one domain? What am I doing? And that's an interesting, and then I'm trying to convince Phil to go get some research money, which he may, and then we could, anybody in their spare time could actually work on a tool, like, the API manager where you got a try it out feature. What if you had a try it out feature for that, where you literally could say, oh, here's an event, and I raise it, and then it's sitting there, it knows how to get it onto the bus, and it knows where to listen, and you see your responses coming back.
That would be cool.
So we're
I
interested in.
looked for such a thing and I cannot find it.
Doesn't exist yet.
Yes,
No.
the community's really struggling to come up with an example. So that's where I went to Phil and said, is there any interest? And he actually is personally interested, as a faculty guy, to maybe do that and then go present some papers to see if we can get this moving in the community of what does documentation look like? And how do I embed HATOS links, and how do I get authorization pass? It's what we're seeing instead is what we're going to see at this conference is ACA is people are saying, the way I do that is I'm running inside this platform that is doing all of that for me.
Mm-hmm.
And well, that's kind of cool. It's not very decoupled. It's not very, okay, BYU Idaho, you got to be in our same ACA domain, and we have the problems working with each other.
I think once we've got a decent start to something, we should probably contact the Open API folks and say, hey guys, got any interest in this?
Yeah, I think that something like what we've got for the Open API, but for an open event standard, I mean, is
Yeah.
I mean-
is something that we need in this day and age where we're moving to an asynchronous
We want
mindset.
Swagger for events.
Yep.
That's what we want.
That's what we want.
Yeah.
And it sounds like we're gonna have to make an initial suggestion,
Yeah.
and we have some faculty guys who might be interested.
Well, I mean, and for now,
Well,
I mean, Helios and JSON Schema will be able to do a lot of that for us for the time being. It's not
Right.
as beautiful as what Swagger can do for us, but in the case of our events, they are a little bit more simple.
Oh, Joseph's brain is going crazy. Of course it is, because I need to read. But you know, right now, Swagger is basically tied to your API, right? It's tied to your application essentially.
Uh-huh.
It would almost be that your event Swagger is tied to your event hub. So if you've got an event hub out there and you want to know what events does this thing have, it just presents you with, here are all the events I know about. So our event hub, our central event hub, queries this database and builds this big document of, here's all of my events.
Yeah.
Maybe add some filtering. and things like that.
Well, and that's kind of been, when we've had those Helios discussions, we've talked about that kind of stuff of being able to have a listener on the event hub that's just listening for anything new. And all it does is consume all of the events just to check if it's aware of them. And then we're very able to produce, this is everything I've seen, because we just have something listening consistently for the pure purpose of storage.
Yeah, we haven't built the analyzer on it, but right now everything
Yeah.
goes to the logging, but yeah, we got to.
Yeah, I mean, but yeah, we could do that.
But one of the things that is, you'll notice, guys, and this is just the thought process, and this is the feedback, I believe that 70 to 80% of what we do could be done in asynchronous APIs. In other words, what Kelly Flanagan says, event-driven microservices. That's what it looks like.
Yeah.
Our synchronous calls should be the minority. Thanks. Give you feedback. Like I said, I'll be adding some notes on here. If you get on there and do it to my personal space, just go out there and look at it, and make snide remarks, fix my spelling, whatever you want to do. It's all public.